Jai Hind to all. Myself Shikha Agarwal, Assistant Professor in IT Department of Ajay Kumar Garg Engineering College. So, today we are going to discuss about the next topic of Unit 4, that is a Transmission Control Protocol. That is, we all talk about TCP. As we all are aware that when I am talking about the transport layer exists between a network layer and an application layer, right? So, in the case of transport layer, there are the certain rules and responsibilities of a transport layer, fine, into which the one responsibility is a connection control. When I am talking about a connection control, we all are aware that it is of two types. Connection control is of two types, that is a connection oriented and connectionless. When I am talking about a connectionless transport layer, it treats each segment as an independent packet in which we need not to establish a relation initially, in which we can deliver all the data packets to the transport layer at a destinated machine, fine. But when I am talking about the connection oriented transport layer makes a connection with the transport layer to the destination machine first before they are sending all the data is being transferred. Once they have established the connection, then only they can transmit the data. Into which, when I am talking about the connectionless protocol, in which we are going to study about the one protocol which is called UDP, User Datagram Protocol, which says that each and every packet is being moving independently, because we are talking about a connectionless approach. But when I am talking about connection oriented approach, here we are going to discuss everything about TCP, Transmission Control Protocol, right? So, in the case of connection control, we are talking about these things. When I am talking about reliability, right, it means we are also rely onto the system, fine, due to which it gives the one functionality of reliability too. The next we are talking about addressing. When I am talking about a transport layer, it is having a one method also for a transport layer, that we are talking about the concept of addressing. In the case of transport layer, we are talking about port numbers, right? Then after that, the last responsibility is a packetization. Whenever we are having a large size of packets, we have to talk about how we need to do the packetization of each and every packet so that it can be easily transported from one source machine to a destinated machine, fine. Now, so these are the four responsibilities of transport layer. Whenever it being asked what are the duties and the responsibilities of transport layer, these are the four main characteristics, duties we are talking about of transport layer. Then after that, when I am talking about transport layer, it provides the two types of connections. One is connectionless and connection oriented, fine. Then when I am talking about a transport layer, it is basically having a messages of larger size, which is being divided into a transmissible segments. Suppose, for example, if I am having a packet of 2 MB, right, and it can be difficult to transmit that packet, either we can divide it into a 1 MB packets. So, this is called segmentation. We have to divide the packets, right? When I am talking about a connectionless and connection oriented packet, into that case, when I am using a connectionless protocol, as I have already told you that UDP is a connectionless protocol, into which we are treating each and every segment as a single or independent message. So, they are being traveled independently. But when I am talking about the connection oriented protocol, in the case of connection oriented, so for example, we are using TCP or SCTP. In this case, first of all, we have to create a relationship between all the segments, and then only it is being transmitted from the source to destinated machine, because initially we need to create a relationship. We need to create a connection between source machine and the destination machine. So, suppose we are creating a source and destinated machine as a connection between them, fine. Then only when I am sending the segment 1, it means we have to given them a sequence numbers for each and every packet, so that when it comes to the receiver side, it would be easy for the receiver to do the reassembling of all the segments. So from here we are going to start about the transport layer responsibility. When I'm talking about the transport layer, one more responsibility, then we can say it is called as a process to process delivery. It means whenever the packet or the message is being coming, then it is being completing the one process, from one process of a source machine to the one process of the destinated machine. Then we can say it is the responsibility of transport layer. So we can say the transport layer is responsible for the process to process delivery. Now you can see how we can talk about the process to process delivery. As we know that when I'm talking about a data link layer, it is called as a node to node delivery. For example, suppose this is a source machine and this is the destinated machine, and it includes an n number of intermediate nodes, right? So when the data or the process or whenever the message is being delivered from one node to the next node, right, then in this role the data link layer plays an important role. So due to which we can say data link layer is responsible for the node to node delivery. Fine. Then after that, if this is the host machine and it is being delivering the data to the next host machine, or you can say when we are delivering the message from one host to another host machine, then we can say it is the responsibility of network layer. So in this case, we can say the network layer is responsible for the host to host delivery. But here we are discussing about transport layer. So in that case, we need to know that transport layer is responsible for the process to process delivery. It means suppose this is an sender machine and it executes the n number of processes, right? So out of all these n processes, when it completes the one process of destinated machine, then we can say it is called as a process to process delivery. For delivering this process, we always requires a one type of addressing which is called port numbers. Fine. Now you can see the example also. For example, this is a transport layer architecture of the sender side machine and the receiver side machine. So for example, if the client makes a request to know the date time, fine. So into that request, it always uses the port numbers, right? It uses the port number of the server machine, generates the data packet, and it is being received on the receiver side of one process of that particular server machine. Fine. This is called as a port numbers. When I am talking about the port numbers, in the previous lectures we have already talked about logical addressing and physical addressing, right? So when I am talking about logical address, it means I am talking about IP addresses. So there is a distinguish between the IP address and the port numbers. Fine. Whenever we on the host machine, suppose this is a machine having this IP address, fine, and it executes the n number of processes, and each and every process is having its own port numbers. Somewhere we are having a one IP, on one IP we are having an n number of processes is being executed, due to which each and every process is have its own address, and that is called as a port numbers. Fine. So for example, if we are taking a request for process 13, which is having a port number 13, so we are taking a request from it, and when it is being combining into the IP header packet, right, here we will put the IP address including the port number. Fine. This is the distinguish between the port address and IP addressing. Now when I am talking about the IP addressing or the port numbers, as we all are aware that IP addresses are also called as a logical addressing, which gives an internet address, right? When I am talking about the port numbers in the transport layer, the range of the port numbers is 0 to 65,535, and out of these port number ranges, it is being divided in the three categories. The first is known as a well-known port numbers, the second is known as a registered port numbers, and the third is called as a dynamic port numbers. right? When I'm talking about a well-known port numbers, there are the certain protocols, its range is being from 0 to 1023. So in this range, there are the certain port numbers which is being fixed and it is being reserved by the certain protocols. Fine. Just for example, if we are using UDP, TCP, ICMP, IGMP, depending upon the requirement, and all these protocols are having a fixed port numbers, right? For example, to know the date time, we have used the port number 13. Fine. Similarly, these all are the well-known port numbers. The range starts from 1024 to 9151. These numbers are called as a registered port numbers. These are not the fixed port number, but initially for sending or for doing the transmission, they have already registered for sending the data. So due to which we have assigned the certain port numbers. These are already assigned port numbers, but they are not having a fully control. So due to which this is called as a registered port numbers. Then after that 14,152 to 65,535. This particular range is called as a dynamic port numbers, which can be used by anyone for a temporary basis, right? Which can be assigned or controlled by authorities, right? So it can be assigned to any individual. These are called as a port numbers. Particularly, this particular range is being decided by the IANA, which is called as a Internet Assigned Number Authority. When I'm talking about we have already discussed about what is IP addressing, what is port numbers, right? So now we are going to discuss about what is a socket addressing, how the socket is being performed, how it is being generated. When I'm combining my IP address with the port numbers and transmitting on an internet layer, then we are talking about, it is called as a socket addressing. Fine. When it takes a port number from the transport layer, an IP from the network layer, and when it combines into a single packet, then we are talking about the one type of addressing which is called as a socket addressing. Now, when I'm talking about a transport layer and data link layer, they are having a common characteristic or a duties or responsibility about the multiplexing and demultiplexing. Into this case, what happens? When n number of processes is being executed, it will multiplex all the processes together and comes onto the IP address, and simultaneously it is being transmitted towards the destinated machine or a server machine, and now it will demultiplex it, it will process the data and finally gives the result back. Now, as data link layer and transport layer having a one more common characteristic which is called as an error control. When I'm talking about a data link layer is also doing the checking of an error, and similarly in the transport layer also we are doing the checking of an error. When I'm talking about transport layer responsibility, it is being checking the layer onto a network layer when the data comes to the data link layer. Fine. So after that, once the data is coming, or once everything is to be come on the data link layer, now from data link layer to the physical network, everything is to be checking of the path is being done, into which the responsibility is of data link layer. They are doing the same thing for error detection and correction methods as we have already discussed in unit 2 of data link layer. Similarly, it will do the same thing, but error checking should be done of the path from data coming from transport to network layer or up to the data link layer. But as soon as the data comes on the data link layer, the error checking method is being done by the data link layer. Fine. This is the way how the network is being checking the error control. Now, as we know that transport layer is providing the two type of services, connection oriented services and connectionless services, right? When I'm talking about a connectionless service, I have already told you that each and every packet is being sent as it is, right? Independently, you can say. So when each and every packet is being sent independently, so we don't require to establish a connection and release the connection. So the first thing is no need for connection establishment and connection release. We need not to do the connection establishment. Second thing, when each and every packet is being moving independently, they are following their own routes. So they are not required to numbering is to be done. So they are not using any numbering system also, right? Second thing, after that, when we are not numbering the packets, may or may not be the packets are following the same route, okay, due to which there may be a delay or the loss of arriving out of a sequence numbers. Maybe they will not arrive reached at the same sequence numbers, right? And similarly, when we are not doing the sequence numbers from the sender side, so similarly in that case we don't require any acknowledgement also. So due to which no acknowledgement is being considered. Fine. Okay. So that is why there is in the transport layer there is one internet model which is called as an UDP. Is a case of connectionless. Now we are going to talk about the connection oriented. Before we transmit the data from the sender to the receiver side, first of all we need to establish a connection between the sender and receiver. Once this connection is being established, then complete data can be transferred, and once the packet is being transferred completely, then we can release the connection. Due to which we are going to study about TCP and SCTP. These two protocols are called as a connection oriented protocols. Then after that we are going to talk about reliable and unreliable conditions. As we have already told that a transport layer can be a reliable as well as unreliability, right? So when I'm talking about the application layer program, okay, it always needs a reliability. We are using a reliable transport layer so that we can implement a flow and error control at the transport layer. It means if we are providing the error and the flow control, it means somewhere it is slower and more complex services, right? So in this case, we can say in that case, the application program does not need any reliability because it uses its own error and flow control mechanism, or it needs such a fast service so that it does not demand for the error and the flow control. Then it is an unreliable protocol can be used, right? So we can say whenever they want that we need to implement the error and the flow control, it requires a reliable transport layer protocol, or if they don't require any type of mechanism, then they are using the unreliable protocol. Now, when I'm talking about this complete architecture, we are going to talk about transport layer protocols. In this case, we know we are going to talk about SCTP, TCP and UDP. So in this lecture, we are going to discuss about a one protocol which is called TCP, or you can say transport layer, transmission layer control protocol. As we all are aware about that transmission control protocol is a transport layer protocol which provides a connection oriented. So we can say TCP is a connection oriented protocol, as well as it creates a virtual connection between the two TCPs so that they can transmit the data. When I'm talking about the TCP protocol, we know that it is a reliable transport layer protocol. If it is a reliable, then we can say it always uses a flow and error control mechanism also at the transport level. I have already told you that when I'm talking about the transport layer, there are the certain port numbers which is being fixed in the range of 0 to 1023. So these are the certain examples which I have given you, which are using the exact port numbers. For example, in the previous example, I have already told you that we are using 13 for the daytime, right, which returns the date and the time, right. So we are using 13 for daytime. In the previous examples also we have used it. So there are the certain port numbers which is being used by the TCP protocol. Now when I am talking about sending data, there is a streamline of delivery. Why it is called as a stream delivery? Because in the case of TCP, we have to create a connection, or after creating a connection, packet is being transmitted from the source to destination. So into which we are sending process is going on. We are streaming the bytes and it is being continuously moving from sender to the receiver side. How it is being storing the data? For example, if it is also buffered. So once the process is being completed, it will having a memory space which is called as a buffer space. It will store the packets and one after another it will be sending the packets. The dark colors is being shown that it is already sent. This is the next packet which is need to be sent, right? And it is coming on to the location. Now after that, these all are the bytes which is to be already received but not yet read. Okay. Then similarly, they have said this is the next byte which is need to be received and so on. This is how the buffer memory space works. When I am talking about the TCP segmentation, as I have already told you, when it is having a large number of packets, these packets is being segmented. As I have given you an example also. So for example, if it is being segmenting the packets, it is being segmenting into this way, and one after another when it is being received, it is being stored into the one after another buffer space and so on. Fine. This is the way how the TCP segmentation works. When we are talking about the TCP, the bytes of a data are to be transferred in each and every connection. They all are numbered. Just say for example, if I am talking about this packet, this is for example 1, 2, 3, 4, 5, 6 and so on. So there is a way to provide the sequence numbers also to the each and every protocol. The numbering starts with the randomly generated numbers. It depending upon the conditions, how we need to generate those numbers. Fine. Now see how we have to provide the sequence numbers for each segment. For example, we are having a large packet and we are doing the sequence numbering. So for example, if we say if the range is 10,000 to 11,000 of that particular packet. So for example, if we give a sequence number 10,001, right? And so on. So this is the segment 1 having a sequence number 10,001, which is having a range of 10,001 to 11,000. Fine. So it means we have done the equal distribution among the segments, and what we did, whatever the first range is, we have given them as a sequence numbers. You can check. So you can randomly choose any sequence number. You can use from 1 or any other number in which you are starting it, and then after that you can provide the sequence number to the whole packets. The value of the sequence number, it always defines the first byte of that contained segment. What we did, we can choose the random numbers. We have already decided the range. So what we did that whatever the first range starts from, we have put it as a sequence numbers. Fine. The value of the acknowledgement field. Now this is the way how we are providing the sequence numbers. When we are talking about the sequence numbers from the sender side, so obviously we require the acknowledgement also. So similarly for the acknowledgement also, what we did, we are using the value of the segment defines the next byte or a party expects to be receiving it. Suppose if I receive a 10,000 sequence number, so I expect 10,000 plus 1 packet is to be received next, in which we are acknowledgement numbers is to be cumulative. Fine. Just say for example, I can show you an example also. Suppose if I say sender sends a packet which is having a sequence number X, right? Then after once it comes to the receiver's end, it will store the packet X, but it will send an acknowledgement for X plus 1, which indicates that I have received the packet X. Now I expect that you will send me the next packet that is called X plus 1. Fine. So this is all about the brief of TCP. Now we are going to talk about the TCP header format, which plays a very important role, and it is also a very important question in the exams. Now when I am talking about the header format, it is being divided in the two parts, header plus data. right? So here we are going to discuss about the header norms. First of all, when I'm talking about the header format, it includes the various parameters. The first is called as a source port address, which includes of 16 bits, which indicates what is the process address of that particular source machine. Then we are going to include the destinated port machine address, right? Then after that, because we are talking about TCP and it is a connection oriented protocol, so obviously we require a sequence numbers as well as acknowledgement numbers, right? So what we did, we are using the sequence numbers as well as acknowledgement, and which will be consisting of 32 bits, right? Then after that, we are going to talk about the header length. So we said that the header length is of 4 bits. We have to indicate whatever the length is, it should be indicates into the 4 bits. Then after that, we are going to talk about the 6 reserved bits. These are the bits which plays a very important role when we transmitting the one packet from the source machine to the destination machine. When the whole complete connection is being established till the release of the connection, these 6 bits plays a very important role. Then after that, we are going to talk about the window size. When I'm talking about the window size, it indicates how that window is being transmitted. What is the size of that particular window, right? The next, we are going to talk about the error control. So here we are using the checksum method. We have already studied about the various types of error control mechanisms. So out of all those, we are here in the case of TCP, we are using the checksum method. Then after that, we are having an urgent pointer. There are the certain points where we need to maintain the urgent pointers. And lastly, we are having an options and padding. Fine. So here we are going to discuss about the 6 problems, 6 urgent pointers. The first is URG. Whenever we are talking about the value is 1 or 0, we are talking about the 2 values only, 0 or 1. So if the urgent value is 1, it means it is an urgent data. Otherwise 0. If it is an acknowledgement packet, it means its value is 1, otherwise it is a receiving packet, data packet. The next is push button. Push button says we need to request, are you in a ready state to accept the packet or not? So that is called as a push for the data. Okay. Now if we want to again establish the connection or reset the connection, then we are using RST. Fine. And if we are synchronizing the sequence numbers, then we have to use the SYN. Fine. And finally, if we want to terminate the connection, then we are using the FIN. Fine. So these are the general pointers which means the same thing. If it is an urgent pointer, then the value of urge is 1. If it is an acknowledgement field, then you can say the value is 1. If we want to push the data, then it is called PSH. If we want to again re-establish the connection, then it is RST. And if we want to synchronize the sequence numbers during the connection, that is SYN. And finally, if we want to terminate the connection, then we talk about finish. Now see how we are sending the packets from source to destination. Suppose there is a client and request server in which we need to establish the connection first. If we want to establish the connection, right? So into that case, it will send a request packet, fine, in which they are doing everything in a form of 3-way handshaking method, fine. Into which what they did, they have sent a packet which is having a sequence number 8000 and it sends the acknowledgement for the previous message which is already received from the server and synchronize flag to synchronize the connection. Once it receives to the server side, what it did, it sends an acknowledgement for that particular 8000 packet, right? And that I have already told you that if it is sending X packet, then it requires the acknowledgement for X plus 1, fine. Now after that, it will send their own data that which user using the sequence number form 15,000. Again, it will also send the acknowledgement for the previous packet and synchronization for the next packet. And so on. For example, if this is the last packet, they need not to send any sequence numbers. So what they did, they will repeat the sequence number of initial stage, that is 8000, and finally it will only do the one as acknowledgement packet, rest the same, right? It means the synchronization segment, it cannot carry the data, but it always consumes a one sequence number to establish that particular connection, right? And if we are using synchronization plus acknowledgement segment, it cannot carry data, but it consumes always one sequence number. Fine. If we are talking about simple acknowledgement, it means again, it consumes a one sequence number, but it always not carry the one packet. But if we want to send a one data, if we want to transfer the data, here we have to use the push flag, right? So suppose for example, once we have already established the connection in spite of synchronization, if the P value, the urgent pointer P push flag is value 1, then we have to transfer the data. For example, we are using the sequence number 8001. So you can check the data which is being transferred having a range from 8001 to 9000 and so on. This is the way how the complete packet is being transmitted. After receiving all the packets, finally it wants to send an acknowledgement, right? They don't want to transfer the packets. So into that case, it will send an acknowledgement, fine, and finally it will give the acknowledgement for that particular sequence number 15,000. This is the way how the data transfer takes place. Because as I have already told you that TCP is having a three-way handshaking. So last is we are talking about the connection termination. Now the client don't want to send any other packet now. So it will use the finish flag is to be 1 to send a sequence number with an X and so on. And finally it receives an acknowledgement as yes, I also want to terminate the connection. So it will do the finish 1. And finally it will send only an acknowledgement because it is already finished the process. So this is the way how we need to do the connection termination. Fine. So there are the certain things in which we need to talk about the TCP. Basically TCP works in a 3 steps: connection orientation, then data transfer, and finally the connection termination. There are the certain things we need to discuss about TCP here. The first is the size of the window is lesser than roundabout time and CWD time, right? Second thing, the source does not have a full, they need not to send a full window worth which is being having a complete data at the same time. The window, it can be opened or closed by the receiver, okay? Fine, but it should not shrunk. It will not shrink the things. The destination can send an acknowledgement at the any time, but it does not result in a shrinking window, okay? And so on. These are the certain points which we came to know about the TCP. So in this lecture, we have already discussed about the TCP header format and certain roles and responsibilities of the transport layer. Thank you.